So we're going to get started. So part of the reason why we even organized this workshop was a collaboration with Pietro Michelucci from the Human Computation Institute through some connections that we made with the NSF Big Data Hubs a couple of years ago. And we did a workshop here in Redmond last October where we noticed that there were a few projects. Franco Pestiri from Indiana University, who's one of the speakers here today, and Pietro, and there was another PI, and we realized there was this theme of crowdsourcing that was emerging from some of our academic collaborations. So then we got together and decided that we should probably, collaborate more with the research that's going on in Microsoft Research in this area. So yeah, we look forward to hearing what you have to say about this.
Well, actually, oops, am I on? Can you hear me okay? Or is it not?
No, it should turn green.
Okay. Screen. Okay. Yeah. Thanks so much, Bonnie. So it's truly a pleasure to be here. I mean, I know a lot of you, and now I get to meet some of you in person and hear more and see more about your work, and it's fascinating. And one of the things that I've noticed, so this whole session is something like crowd, cloud, and the future of labor, and what I've noticed is we're talking a lot about how do we insert humans in the loop and create these human-AI partnerships? So what is the nature of the human involvement? And so for me, this was kind of an indulgence, this talk, and I'm hoping you'll join me in this indulgence, and this can be a conversation. But I'd like to sort of shift us out of the space of the sort of technical ways that we can create these combinations and think more about what we actually should be doing and what the implications of that are for the future of labor and society. And I want to acknowledge my colleague Agla Maria Romanowskaite, who actually created most of the slides, thank goodness. So I'm throwing a party tonight. You're all invited. I'm making homemade sangria, but I have a teensy request, which is that my neighbor really needs to get his lawn mowed, and I'm just hoping that maybe, Lucy, there's this one area in the back of his lawn. If you could just mow that area, I'd be happy to roll out the carpet for you tonight and invite you in for some sangria. So is that okay? What do you think? So this model kind of happened in a way, right? So I mean, probably everyone in the room, has used some version of this slide in some talk. But most of the people who participated in reCAPTCHA didn't realize that they were providing labor. There was a quid pro quo. Like, I want to get into this website, and if I digitize this, I get in. But they were helping to digitize back issues, archival issues of the New York Times, dating back to the 1800s, and that digitized archive exists now. And if you go, has anyone here tried to go and look at those archived issues? No? So I hadn't either until last night when I was thinking about this. And it turns out that you can, but if you're not a subscriber, you have a limited amount of access to it, and not so limited in the scope of what you can look at and how many times you can look at it. But I was one of the people who filled in these reCAPTCHAs. Shouldn't I be allowed to see all of it? So something's changing. There's something new happening, and so Wikipedia defines the knowledge economy as the use of knowledge to create goods and services. And this is a buzzword. It's used in a lot of ways. But I think what's upon us now is a thinking economy. And that's eking into the space of all the different applications we're talking about today, and in other applications we haven't discussed. And so I would say, if I had to make up a definition, what do I mean by the thinking economy? It's the use of information processing to solve problems. So humans are information processors, machines are information processors, bacteria are information processors. And an economy isn't just about money, right? I mean, when I hear economy, I think money, but it's about supply and demand and exchange of labor and goods, or labor for labor. So there are implications of this shifting to a valuation of information processing. And so yeah, this is a well-known Led Zeppelin quote, and it's kind of tongue-in-cheek because, yes, there are two paths we can take. There are multiple paths we can take. And I would argue that changes are happening around us, and we need to start thinking about these things and deciding now. We can't wait. So has anyone here heard of multiverse theory? Sure, yeah. Well, yeah, Lucy, of course. There are an infinite number of Lucys. That's a wonderful thing. And so there's a version of our universe in this theory that includes every possible outcome. And there's indeed a universe in which I get to spend weekends playing chess with my buddy Bill. Unfortunately, I don't live in that particular universe. But whether you believe in infinite universes or not, there are infinite possibilities for our future, right? And our labor economy, our society, our culture, and human civilization itself is co-evolving with technology. And we have no idea where we're going to be in 20 years. There are lots of opinions, but we really don't know. But the good news is we can influence that. And that's what I'm really interested in thinking about and talking about together. But the only way that we can understand where we are, the only way we can influence that in ways that are meaningful to us is to understand where we are today, where we want to be in the future, and then try to figure out what are the intermediate steps to get there, right? Basic stuff. So where are we today? Well, some of you probably remember the dot-com bubble. I would say we're in the middle of an AI bubble. That would probably provoke some interesting conversations with some people. And AI is great. I love AI. And machine learning is more practical than ever, thanks mostly to Moore's law, but also to some clever innovations. And AI is getting better, but it's not really putting people out of work. What it's doing is it's changing the kind of work that people do. But AI is going to continue to get better, and we need to be ready for that. So what does that mean? What does it mean to be ready? How does shifting to an economy in which human information processing is highly valued, how does that create an opportunity today for us to build a future we want to live in? So we have to decide together what this future will look like, and then figure out step by step how to get there. And we might not figure out all the steps at once. Okay, but what's the next step? What should we be doing now? So yesterday, my weekend chess buddy Bill, in my dreams, brought up something really important in a really clever way. He said, an email tends to not be a random message going to a random person. And this is the context issue, of course, right? And it reminded me of my new uninvited Gmail bot that tries to tell me what I should be saying when I'm typing an email. I get an email, it reads the email I got, and then it tells me what I should say back. This is very unnerving and very uncomfortable, by the way, for me personally. And I have these, and it gets me into these like endless, infinite, horrible loops of, well, that's not exactly the way I would say it, but geez, is that better than the way I would say it? Or that's exactly what I was going to say, which makes me want to do something different. who's this machine to be guessing? Is it studying me? How does it know I would say that? And human communication, social communication, is extremely nuanced. And I might not realize what I'm doing, but I feel like the way I communicate has been effective. And now I feel like it's being changed without my consent. And you know, so this kind of illustrates this idea. Yeah, my colleague found this one. So, you know, context is obviously everything. And when we can see telltale signs of trouble like this, I think we need to call them out and head them off. You know, and AI, quite frankly, sucks at context. I'm just going to say it. And that's why we need humans in the loop. So, so this is one way that humans add value, I think, in terms of information processing. And maintaining human representation in the broad space of thinking helps ensure that we have a say in what happens next. So by inserting humans in the loop today and being part of these information processing systems that have many automated components, we can remain influential. And there's another aspect to this, which is that, you know, the holy grail for generalized AI is to achieve human-like intelligence. We have human-like intelligence. It's called humans. And what we really need to solve today's problems and tomorrow's problems is superhuman intelligence. So, and I believe the only way to achieve that, at least today, is with humans in the loop. And I think it'll be that way for some time. So I want to tell you about some human in the loop approaches and how they're shaping our future. So 3 years ago, my colleagues and I created an online game called Stoll Catchers that anyone can play. And by playing Stoll Catchers, you help accelerate Alzheimer's disease research. And we ran a team competition. It was a month-long competition to test our new team feature. And so this Lake Hazel Middle School in Boise, Idaho, created a team of 250 students that were extremely competitive, and it was a neck-and-neck competition with the retirement community until literally the very last day of the competition, when the teacher held a pizza party and invited her students in on a Saturday to win, and they did win the competition. So I felt compelled to go out and thank them in person. I gave them the first Citizen Science Trophy, which sits in the case next to the football trophy. And they had an assembly, and I got to speak with them and thank them and recognize their contribution. And I said, you might think I'm here to tell you all to become scientists. I said, I don't care if you become a scientist or not. I just want you to recognize that you used science to solve a problem. It's a tool, and it's a powerful tool, and it's the best tool we have today to solve problems. And you did it. You know, and someday, you know, you're going to tell your grandchildren, you know, who have their AR, their augmented reality, you know, glasses on, and they're doing all kinds of cognitive labor. You're going to say, I was there at the beginning. You know, we started this. Hopefully they don't hate you. So in 2014, I organized with some colleagues a workshop at the Wilson Center called the Human Computation Roadmap Summit. Some people here were there. Paul Bennett, who was in the room a minute ago, was there, and Stephen Dow, who was in this picture, was there. And we had, so the purpose of the summit was to say, what are the new capabilities we can create with humans in the loop? And what are the research areas that need to be pursued in order to achieve those human-in-the-loop capabilities? What's the missing research, and what are the applications? So we had breakout groups, and this group was about the future of work. And so you know, Stephen and Marcus Krauss came up with this idea that they called pathways to radiology. And the idea is that you know, you do it kind of like as a volunteer in citizen science. You get these radiographs and you help do a diagnosis. You say, oh, I think there might be a cancer. There's a big splotch in the middle of this lung. You know, it could be a problem. And then you aggregate it. And then over time, you're measuring expertise, and these people become certified based on the skill that they demonstrate in the system. And once they're certified, maybe they start getting paid for it. And then you take only the most challenging ones, the ones where there's the most disagreement, as in VizWiz. You have the most disagreement among all these sort of public volunteers or paid certified workers. So then you give those to the expert, to the radiologist. You're making the best use of the radiologist's time because the radiologist is only focusing on the ones that require that level of expertise. So something really cool happened. Doesn't happen very often, but something that an idea in a workshop turned into an actual platform. And so Marcus Krauss took this idea a level further, and he wrapped MOOCs into it. So people are studying, and businesses are providing data sets to support these MOOCs. People are doing crowd-based analysis on the data. Their performance is being monitored. They're learning in exchange for this. At the end of it, they have a credential, which is their performance on the data set, which becomes part of the resume that goes to the organization that delivered the data, and they hire them as employees. And they've had several successful examples of this where people now are cognitive laborers because of having gone through this MOOC process. So someone mentioned this earlier. I think HA maybe mentioned in her talk. So, driverless cars. Does everyone know about how Nissan handles the driverless car problem? No? OK, so this is really cool. There's an article in Wired magazine. So the idea is that when a car gets into a tricky situation that it can't handle, it calls a human-powered call center. And then all the car telemetry goes to the call center. And then the person either commandeers the car or sends the right data back so the car knows how to get out of the sticky situation. So people who used to drive cars around now work at the call center solving the problems that the cars can't solve. So this is I think this is a very interesting and example of the shift in how labor happens because of what we're able to do with automation. And it raises these ethical issues. I think that was the part that was in HA's talk, which is kind of the idea that if you're a human driving a car and you get into a sticky situation, you have 1/100th of a second to make all kinds of ethical, moral decisions about do I go through the shop window and I don't know if there are people there, or do I hit this little pedestrian over here? But now we have to actually figure those things out and build them into the systems. OK, I see I'm kind of running short on time. So anyway, bottom line is we need to decide together what this future will look like and figure out step by step how to get there. So what's the next step after these systems that we have today? Well, I think it's the work that many of you have already described. In Stoll Catchers, we're also experimenting with these human-in-the-loop with human AI partnerships as part of the citizen science platform. So we, in Stoll Catchers, the basic, it's a simple binary classification task. You have to decide if a blood vessel is flowing or stalled. We draw an outline around it. But who draws the outline? Well, we have an algorithm now that does that, that is based on work done by iWire and then extended by a member of our team. So that's completely automated. Some of our movies are bad. There's an outline, but there's no vessel in it. So we have to find those. Well, we have humans flagging those, but we also are building a machine classifier to find those as well. And of course, the human data, the human flagging data is helping to feed into that. But that's not an automated process, and I think that's an important point. We take a data set, and we bring it over here, we put it in the machine learner, and we train it, and then it gives us an output, and it's pretty good, and yeah. But it's not quite good enough, and when it is, we'll eventually hook it into the system. But there's all this manual connecting of things, and I think that's a big problem. I think that's one of the stepping stones. And then the main thing the humans do is classify the vessels. So if the answer were in the pixels, then the machine would be doing it. But machines are only 85% accurate because there's context required. There's knowledge of physics. So I think we're working toward more elaborate systems, more complex systems. We need tools to get there. And ultimately, you could say, when you're at an AI workshop, it's all about how do we build the best AI, or You know, when you're at a DARPA-sponsored thing, it's how do we build the next best thing to give us an advantage over our adversaries? But what if we just pop up above all these levels and say, what do we really want to do here? Well, wouldn't it be interesting if the Earth system becomes a massive super prediction model that basically self-adapts and maintains homeostasis, kind of has an organismic, and I feel like that's one trajectory. And maybe that's not the best thing, but sometimes it helps to have a light in the distance to aim for. So a few stepping stones that I'm just going to put out there: put humans in the right part of the loop, prepare our children for the thinking economy, reinvent equitable reward systems, and importantly, create tools for studying humans in the loop that give us the ability to reuse and extend the work that we've done, to share data sets, to share algorithms, and to work together more fruitfully. So our vision is evolving, and in the end, I have no idea what the future should actually look like, but I think we want to make sure that we keep humans in the driver's seat in the ways that matter most. Thank you.
Questions?
Not just questions, I want to know your vision for the future.
Hi, can you hear me? OK, great. What are you thinking of? Is it off?
It's a very visionary, great talk, and I'm going to ask a little bit of details about what you're thinking we should go for, the next thing. I mean, Vani introduced how we've been talking for a while about the possibilities and the problems that some of the new platforms are generating. And what do you think, from your point of view, the intersection between the other talks we've seen today, AI, and the human contribution should be? What are the opportunities that we're missing now? Like, what Alzheimer's one? What else would you go for, and what are the low-hanging fruits that you would address?
Oh, the problems that we can solve
Right.
with these methods. Yeah. So I mean, we have a lot more experience today than we did 5-10 years ago with microtasking. And what's exciting about some of the work I've seen today is that I'm seeing pipeline processes where humans intervene at different levels in the process. I don't think we've exhausted microtasking or versions of that for solving problems, particularly in the health space. And I think in those contexts, I think the work that's being done today that's been described that explores kind of the best ways to manage these, the most effective ways to manage these partnerships in terms of the pre-processing algorithms that massage the data and put it in a form that's really kind of plays to the strengths of human perception and cognition. So I think we're thinking about use cases now in life-threatening arrhythmias, in macular degeneration studies, in diagnosing kidney disease, and lots of other kind of health-related areas. And my lens is kind of on that because of the work we've been doing. But I think the space is wide open, and I think there's so much interesting work to be done also in education. And I didn't really talk much about that side of it, but I think there's you see a lot of informal learning going on as people participate in these systems. And we have graphs that show increases, quantitative and qualitative increases in knowledge and capability in the people who participate in Stoll Catchers.
You just mentioned like heart arrhythmias or other sorts of medical. Are you imagining that crowd workers could be used for sort of real-time diagnosis or detection or to help those sorts of things? Or is it still more on the sort of labeling or on the research side?
I would say yes to both in a sense. So what I mean by that is that depending on the application, I think there are some cases in which it's labeling and then it's advancing research. There are direct real-time clinical applications or clinician-supported applications, I think, that can also be pursued. And I think the tricky area there goes back to this whole, my little Google friend that tells me what I should be saying. That, when the clinician is sitting there and the AI says, well, I really think this is this, and I really think you should give this treatment, and the clinician's like, geez, that wasn't what I was really going to say, but now that you mention it, well, you might be right, and causes this kind of, how do we, that's a very challenging space to tackle. I think that's the space you're tackling. Yeah.
I guess the crowd could be like the lifeline, and in the Millionaire game show, maybe I could have an expert and a crowd and my own opinion.
I think that's a really interesting model to explore, and I think, again, having a platform that makes it easy to stand up models like that and play with them and test them out could be really useful. So, we're certainly looking at use cases where we want to have real-time, we want to have a machine-based system that's doing a kind of an evaluation that's related to a health topic, except that we can't fully trust the machine. So how do we set a threshold on the machine to say, I'm really not sure about this, people need to look at it, and then send that to the crowd. So that's, I think, one version of that. Yeah.
So next up we have Lucy Fortson from University of Minnesota. We are running behind schedule. We're just going to take time out of the breakout session, and then we also have lunch scheduled as part of the workshop, so we can continue talking through lunch if people want to keep talking. Thanks.
I have to hold it. I don't have pockets. Yeah, okay. I think it's on, though, right? Yeah, okay, perfect. Okay, and I'm a wanderer, so I will do my best. You can just, signal me to go. All right, so this is great. Pietro set some fantastic vision, and I'm going to get down into the weeds a little bit more and tell you about the Zooniverse platform and what we're doing both on the machine side, but also trying to understand our volunteers. And since this is sort of future of work, and some of us are volunteers without even knowing that we're volunteers, and reCAPTCHA, every single time I do a reCAPTCHA, I had to do it last night, I'm like, come on. Identify the chimneys, isn't that obvious that, I'm giving you my, my labor? So volunteers, what motivates the volunteers to participate, and how can we best combine human and machine intelligences together? And so I really like this concept of sort of help me to help you. So, well, who is the subject in this, right? Is it the machine asking the human, or is it the human asking the machine? But so that's sort of the setup there. All right. So firstly, I think a number of people know about Zooniverse, but I just feel like I have to give some grounding in what it is. So it started with the Galaxy Zoo project in 2007, and we'll come back to Galaxy Zoo a bit later. We currently have a little bit over 1.75 million volunteers worldwide, over 150 projects. As of last night, 432 some odd, nearly 433 million classifications. And one of the things that we try to make sure differentiates us from other citizen science projects, and this isn't a value statement, I have to be very careful to say it, it is just what we feel we should be providing, is scientific outcomes. So we do require that the science teams that work with our platform do their best to obtain at least one peer-reviewed published paper out of the data that they have collected from the citizen scientists. Otherwise, as other people have alluded to, it's kind of a waste of volunteer effort. And the volunteers like to see they know kind of what the currency of the realm is in the scientific disciplines. They know peer-reviewed papers are important. And so they like to see that their data have been used in peer-reviewed papers. And we'll come back to this topic in a little bit as well. And so, yeah, you can play the game of what the total gain, if you will, is to the system based on the volunteer workforce. And so we have a project page. You can go in and you can filter by discipline. You can filter by most recently launched, by the project that needs the most help, by a variety of different filters to get to the project that you would choose to work on. And so these are the different types of tasks. We started a long time ago, again, over 12 years ago now, building up a repertoire of sort of task modules, things that we found different science teams required, and we abstracted them to specific types of tasks, which of course can be used in different disciplines. And this is just a couple of examples. So this is a marking task, and this is just the UI that the volunteer sees. And this is a freehand draw tool. Of course, this is something that a machine finds very difficult. And this is a survey task. We have a lot of camera trap projects where you want to identify specific animals in the images. And you can reuse that same type of infrastructure, the tool, the survey task, to do a gravitational wave categorization problem too. So that's just to show that these underlying tools are generic in that sense. And so, of course, we can also do annotation or transcription. So those are just a few of the types of examples. We have then, as many have alluded to, I think most people in this room know how this works, but just to go through it. So the idea is, many brains make light work. You need to develop a consensus of all the different labels that have been provided through a given task or workflow. And several people have alluded to already, this is where a lot of optimization can be done. How many people do you actually need to tell you if a spiral galaxy is a spiral galaxy? Do you need 1, 2, 5, 100? Well, of course, that depends on the difficulty of the image, and as people have said, how you phrase the question and the context and the information that the people bring to the problem. At the end of the day, however, you do get a consensus answer, which the science team then uses for their, hopefully, publications. So this is just to sort of show the impact, which is pretty impressive. This comes out of a Watson and Flaherty review of a large number of Zooniverse projects, and then just compares, this is the citation percentile of 62 of the data sets of publications that were used by Zooniverse compared to the 5,500 publications that use the very same publicly available data sets. And their, just the density distribution of citations and the importance and relevance of the papers that have been produced through the Zooniverse work as compared to the generic scientist not using the citizen science method. So how do we enable research teams to use our platform? Well, in 2015, we launched Project Builder, in which you can sign in and very easily put together a project. We have sort of 3 basic ways people use the system. Predominantly, it's, this intention is to launch a project that the general public has access to. It goes through a beta testing phase where we have 100,000 volunteers signed up to actually do beta testing. They get the research team gets feedback, and then They use that feedback to improve their project before they actually launch it live. The second way is you can have, let's say you may have a small data set, 10,000 images or something like that. It doesn't make sense to launch it to a large volunteer audience. And maybe you have a set of undergrads for the summer that you just want to gather some labels on something, and you can just use the URL to pass it around your team. And then the third way is if you have privacy issues, human research issues, and you need to have it behind the firewall. So at the end of the day, this is our, our growth over time. We started off in space. I'm an astrophysicist. Yes, I know what a multiverse is. Do I believe that they actually exist? Why not? Everything comes down to the quantum foam, right? But so you can see that we're beginning to be dominated by our ecology projects right now. And, the astrophysicists amongst us are, keep trundling along. But and we're moving more into, and we hope to continue to move more into the biomedical areas and other areas. But so this, you can see the launch of the project builder. Basically, our growth sort of exploded at that point. And I just want to point out, this is not a cumulative distribution. This is the number of projects launched per year. And I could show you a different graph, which is some of these projects, of course, finish within maybe 2 months. Some of them stay live for over a year or more, or 3 years or something. So if I did do a cumulative distribution, it would be even more impressive. OK, so where are we going? Where have we been? Where are we going? So Galaxy Zoo, the context in which Galaxy Zoo was launched, there was the Sloan Digital Sky Survey that had 1 million images that needed to be classified. And this was a research project for one graduate student. And so back in the bad old days of 2007, when deep learning wasn't really a thing, and big data was actually spelled with a little b and a little d, 1 million galaxies, that was a lot, but you could actually get the volunteers to go through each one of them, okay? Yeah, and that was great, and it was awesome, and it was good, and those of us who started the whole, project, we realized we were on this wave that, riding this wave that was just, only getting bigger and bigger and bigger, and so now we're at this point where instead of the Sloan Digital Sky Survey with 1 million galaxies, we have the Large Synoptic Survey Telescope, which is going to generate 20 billion galaxies. And it doesn't matter how many people you recruit to the platform, that is just not going to happen. So citizen science needs machine learning, but as many people have pointed out, you need both the humans and the machines. You can't just hand over all the data to the machines, even if you have a few labels provided by the humans. It's not just astronomy. This is our first camera trap project in the Serengeti, launched in 2012. 7 million images just for the first 6 seasons, launched in 2012. This is our growth in camera trap projects. Boy, people thought that was a great idea. So they jumped on the system. And again, with the project builder, it made it very, very easy for a research team to put together a survey project. So how are we going to introduce machines into the system then? So one of the ways that you can do it, okay, so you've got all these data, and you can, get clever people to train machines for you to, in the first instance, eliminate the empty images. Okay, so images that do not have an animal in them. And so if you trust your machine completely, okay, but machines, as we've just heard, they make mistakes. So what you really want is you want a system whereby you have a machine predicting an image to be empty, but then you actually need just maybe 1 or 2 or 5 validations from humans. So again, this is all about retiring subjects. We call it the images in the system as subject. Retire subjects faster. So you just use a threshold on your confidence score. You have the, after you put the data through the machine model, you upload to the Zooniverse. Then you use this, what we call a cascade filtering workflow. So you recognize that a binary question, whether it's empty or not, is actually easily done on our mobile app because people are standing in line at Starbucks, they're bored, okay, so they tenderize whether or not there's a animal in the image or not. So, so that we found actually works very well, and then we can move images that do have an animal in them into, well, then you can have, like, in some cases they're vehicles, but eventually you move them into the workflow, which is really just identifying the species. And in this experiment, which was published by a graduate student of mine, oh my God, it's Willie et al. Why do I not have him up here? That's bad. Okay, so anyways, we found that 43% fewer volunteer classifications were required to keep, assuming same accuracy. Okay, so that's the simple way you can introduce machines onto the system. You can get really complicated if you want, and really, super clever. This is work by Mike Walmsley from the Oxford crew of Zooniverse. This is, in fact, what is now live on the Galaxy Zoo system. And this is an active learning algorithm in which, using information theoretic methods, the machine learns to figure out which image is the next best image to get a human label on, and present that image to the next person. And I see my time is up, and I'm only partly done. I will do my best to go fast. So this is the list of all of the different ways that we can incorporate machine learning onto the system. But the problem is that a lot of our science teams don't necessarily have the background on how to implement machine learning. So we're actually collaborating with Microsoft right now with AI for Earth and Dan Morris and co. To try to find a way to offload the responsibility from the Zooniverse platform and get people such as ecologists who may not be good at machine learning, and Microsoft provides that service, and so trying to find a way to enable that service. Okay, so why do we need humans still? Well, we have this thing called the Zorilla problem. Lurking in all of these images, there can be very rare species, so the data set is unbalanced. That's a Zorilla, for those of you who didn't know what a Zorilla was before. Only 7 out of 10 million images contain a Zorilla. Very unbalanced data set. So this also leads to the point that discoveries can be made by humans. Sure, machines can make discoveries, but humans have that innate ability to ask, what the hell is this? And so this is just a collection of several of the discoveries that have been made. And now we want to get into the whole volunteer side. Why are humans motivated to participate on this? Our volunteers feel that contributing to research is what they would like to do. And this is just sort of a distribution of the, I'm sorry, the map doesn't show up very well. But it's, basically in English-speaking countries, as it turns out, although we do have a translation service on our platform as well. So this is sort of the age breakdown. And I'm going to fly through these since I've run out of time already. You can see that we do have, we're pretty highly educated, which isn't too much of a surprise. And we have a high, relatively high number of retired people, but again, a large number that are employed. And we know that the distribution of employment is everything from somebody who stocks, who's a stocker at a pet store, food supplier, all the way up to lawyers and doctors and astronomers and whatnot, so a full range. We also survey ways in which people get to the Zooniverse platform, and you know, this was quite interesting to us. We actually thought a lot of it was word of mouth. There is a lot of word of mouth. We also thought broadcast media, but what was heartening for us is that people just sort of stumble on it. Okay, so a couple of things that we've learned along the way. People don't like competition on the Zooniverse. Okay, this is not necessarily a surprise to some social scientists, but they did definitely not want to see leaderboards, and we found that out in some sense the hard way. This is also just to show that most of our projects have the sort of a classic Gini coefficient range, and a distribution, sort of a classic distribution of the you know, sort of this Pareto or power law. Most people provide a few number of classifications early on in the lifetime of a project, except for the Supernova Hunter project, in which the data was released weekly, and this turned out to be our most biased gender sample of volunteers, mostly skewing towards the male population and highly educated, and we feel that this may have something to do with the competition aspect of knowing that there's going to be a release of data, and they want to get on the system to get to discover the new supernova hunters. We found, you know, that people wanted more ways to track progress. They wanted reminders when projects needed help. So the way we created new ways of engagement on individual landing pages, and also at the project level. And finally, sorry, I really went over time. So the one of the most important things was that they wanted to have more engagement with scientists, and this just shows with several metrics that show public engagement versus contribution to science, that it's the projects where the science teams actually engage the most with the volunteers that actually contribute to science the most as well. So that's actually an incredibly important takeaway message. But humans are really complicated, so if you want to add machines and humans together, I don't have time to go into what that means, but we all need to keep in mind that the human is a complicated machine, if you will, so we have to keep that in mind. And how do we message to the volunteers that they're working alongside machines and how that actually changes their response? And so I'll just leave it at that. How to best optimize this platform to give the best human-machine partnership for science discovery. So thanks, and I apologize for going over time.
No worries. Thank you. So should we move on to the last talk, and then we can take questions maybe at the end?
Hi, I'm here. Thanks for inviting me. It's fantastic. It's been fantastic 3 days for me to experience everything Microsoft is doing. And also, I'm fascinated to be, I believe, one of the only neuroscientists in the room. And it's been happening for some time to me because I've been working on platforms and in the computer science world and engineering world. So I'm here today to present BrainLaughter, the platform that we've been working on it for a couple of years now. We've been receiving funding since September 2017, initially NSF, and now also we got Azure credits to do some computing. So I will give you a 2-minute short version on neuroscience. We're trying to address many questions in neuroscience. The idea is to understand and improve human health. And there's questions in neuroscience that address issues such as how do we make decisions? How do we make decisions now? How do we save our life? Why did that choice made a turn right or left? And those are events in our life that happens in milliseconds to seconds. But there's also questions that we're trying to address that deal with very long-term processes, such as aging, happening now to all of us, and development that used to happen to us a long time ago. And for all these type of processes, you can imagine there has to be different types of measurements and data that we need to acquire. Indeed, neuroscientists have developed over the years many types of data. This is a plot that goes from time on this axis and size on this axis. These are scales of measurements. In neuroscience, we have measurements that are as small as a synapse, the connection between two neurons. But some measurements go all the way to the whole brain. We can measure from milliseconds all the way to days and months. But each one of these squares is a different type of measurements. And these measurements are different. They provide different types of data. Some data is electrical data about electrical activity in the brain. Some data is imaging data, like biomedical imaging data. And they all provide a different view, different windows, I'm calling them here, on the brain. So some of these measurements are pretty good at addressing questions such as decisions and fast-acting events over life. Turns out those measurements are best suited for measuring in animal models. In humans, they're invasive. They're fast resolution and high resolution. Other measurements are better suited for humans. They're not invasive, and they give you a different type of data and also different type of scale, different windows on the brain. The work I'll present later mostly will focus on this human side, even though we are actually working on other side. So this is a landscape of the brain data that we can currently collect, and we're currently collecting across the world. And that's where I want to go next, across the world. It turns out, even though this is not a picture of what I'm not talking about, couldn't find the picture, there's an uneven distribution of data being collected across the US and across the world. There's some parts of the world that are really good at collecting some type of data, and other parts of the world that are not. There's other parts of the world or institutions that are really good at computing or at software, but other institutions are really good at neuroscience, neuroscience anatomy, or neuroscience function. Okay? And historically, this landscape has not been addressed within neuroscience. Well, one way to think about these measurements is that this is what I call an old picture in neuroscience. We used to look at pictures like this were fundamental for us to understand how the brain anatomy was organized, how the small cells inside the brain and make you think were structured and connected to each other. But like with all these measurements, what we really do, we were incurring into a process of digitization of the human brain function and structure. And one thing that happens with digital is that digital goes to scale. And that's an opportunity that is just becoming real in the last maybe 10, 15 years. Neuroscientists have been acquired tons of data, and computing, Moore's law, introduced before by Pietro, is helping us. We are in the position now to start asking questions that are the scale across population that hasn't been addressed before. Now, I told you before, different institutions, different regions, different states, different counties are much better at some part of neuroscience, okay? But at the end of the day, to do research, once the data are collected, there's three main axes that have to come together to actually analyze the data. The code, software, the data, the actual collection of data done in different institutions, and computing. And these three axes are not trivial for many of you, definitely not trivial from the departments where I've been hanging out, psychology and neuroscience. You had to put together the computer with the right hardware, the right size, install the software packages you need so that the software works. You need to connect to the right lab to get the data, et cetera, et cetera. There's a lot of human intervention in all these steps. I'll give you an example of my experience. So that's Dan. my graduate student, started about 4 years ago. It's about to graduate. And I worry, probably many of you have graduate students, worry about him leaving the lab and leaving some software somewhere on the computer, and I don't know what that software does anymore. And he goes and gets a company job, maybe at Microsoft, and then what, right? In 5 years, a colleague calls me, oh, I really like your work, and I would like to use it. Can you share the code? And I'm like, OK, I'll try. Sandra, it's a different experience. She's a fascinating collaborator. She's interested in the human eye. She has data from the human eye and wants to understand how reduced vision impacts the brain. This is something we don't think about, that my lab is working actively, right? When we lose vision, the reduced inputs actually changes your brain. And we're just trying to understand, we've done some fascinating studies, trying to understand how that changes your brain and what type of processes are initiated. So Sandra comes to my lab and we work and I teach her something, goes back to her lab and try to struggle installing everything. She's in a clinical context, okay? She doesn't have engineer and software engineers around. She has to struggle with the software. Marta is the opposite cookie. Marta, I want to work with Marta like I want to work with you guys. I want people that know machine learning. I have data. We're collecting data. We're gathering data. We want to do smart things on these data. So Marta is a computer scientist, and we're working on trying to understand completely new ways of formulating how we should structure brain data so that we can do better machine learning on it. Lior is a different collaborator. He's in a small college, no PhDs. Okay? They teach image processing and engineering, but they have no neuroscience project, right? Can we bring neuroscience to Lior and students? Can we have his student contribute to neuroscience in a different way? And then there's Holly. She's also a collaborator. We're trying to understand stroke. We're trying to understand how stroke might spare part of our abilities, when that happens, which circuits of the brain are still connected when after a stroke you recover better than other people. And that's me. And the way I do this, I collaborate, I call, I send emails, I use maybe technology like Slack and Team, and I go on and on and on and do all this work. For every one of these collaborators, there's data, there's computing, and algorithm. We need to make sure that they're using the right data files, the one we agreed on, the right algorithms, versions, et cetera, et cetera. And they had to reinstall everything every time they move. Well, because of this, we started working, and because of issues like this, we started working on a project called BrainLaughter.io. This is a platform that is supposed to bring together collaborative efforts from different institutions, from different fields of science. The platform provides basic mechanisms for registering an analysis, a piece of machine learning code or a piece of analysis that we do in pre-processing of these images. It becomes an app on the platform that can be reused, and I'll show you a little bit later. Data sets can be uploaded on the platform, like many other platforms do. And they're registered in such a way that the platform understands what type of data set is and what type of apps can act on these data sets. So there's a little bit of intelligence that we're building into the platform so that apps and data interact with each other. And the other thing that we care, because we are publicly funded, and we're a research enterprise here, so we actually put a lot of effort in making sure that the back end of the computing side was flexible. So we can actually handle different architecture, HPC or cloud systems can all run, and we can be on different cloud systems. So now we are on Jetstream, which is an NSF cloud system, the first. We're on Azure, and we're also running on several HPC clusters from different universities that are partners. So what this means is that we're pushing data, taking data from different clusters and different institutions and doing analysis where it's most convenient. The platform keeps care of efficiency of the app on different systems. There's a priority set inside, so we kind of know a little bit about where we should be processing the data if the compute system is available. And the apps are basically GitHub repositories. very lightweight. It's your code. It's everyone's code with a little bit of a requirement that the platform needs to read from a JSON file, write to a JSON file the outputs. And it's almost like that. Obviously, it's always more complicated than like that, but it is very as simple as that. Apps can be Dockerized, or we use Singularity so that we can run them on cloud and HPC, or it can be Python code or MATLAB code. Actually, we have some licenses on the public cloud that will allow us to run licensed code like MATLAB. And so these are the clouds that we do. As I said, we use mixed systems. And the platform is supposed to help the scientists manage this whole complex workflow, right? Supposed to help you know which data you're computing, where they are, it's under your project, et cetera, et cetera. So what are the goals of the project? Well, we're trying to enhance the work of scientists. Right? We're trying to improve the way the normal workflow of scientists happens. Things end on a desk or under a desk on a hard drive, and it's really hard to track provenance of data and code. We're trying to connect different communities, trying to create opportunities for more computer scientists to come and analyze data or try their algorithms. We're trying to promote, at the same time, sharing data, because we believe there's questions we're not addressing in neuroscience because of the lack of volume in data. There's questions that require understanding variability across measurements devices and institutions, areas in the world, and populations that we cannot currently address. Also, we're trying to upcycle the long tail of data, right? Most data in neuroscience gets collected for a study or 2 or 3 or 4, and then disappears. That data could be very useful for developing a denoising algorithm, for example, to know that some algorithms are good fit for low quality data or better for high quality data, et cetera. So that's what a process we call upcycling. And that's the first paper we published describing part of the platform, and I'll give you a sense of what we're doing. If you come to the platform and use the apps that the platform has, and if you use some data or import your data, you are actually allowed by the platform to publish in a single record with a single digital object identifier all the workflow, all the objects, all the assets you generated. So I think I have a little video of this. OK, so that's the landing page. We're entering now the platform. There's an app. There's a project area. These are all the projects that I can see. Some of them are private. Some of them are public. These are the apps. The apps look like any other app store, even though this is all free. There's a publication page. And now we have a few publications coming up. The first one is this. The one I project. This publication is a single record through a DOI, has instruction how to download the data, how to reference the data, who was involved in this project. And the release, there's multiple releases. There are snapshots of data that has been changing over time as what we call data types. Data type, for example, free surfer is very common in neuroscience. Everyone knows what free surfer is. It's an anatomical analyzed data set, and you can look at it. So this is how data set look. It's a visual interface to allow to run here common software. This is not our software here. The visualization is from Harvard, MGH. And at the same time, there's a different data set that I'm going over to give you a sense. You can download the whole provenance of this data set. These are all the apps related to this data set that the app suggests. And this is all that happened to that data set. 2 initial data sets. This is all the apps that were used to generate the blue data set at the bottom. And the apps are registered all the way down to the Git commit so that you can go back and reconstruct. Now, I like what Lucy was saying before. We actually have the same philosophy here, where we are trying to develop the platform in a way that is useful to scientists. So we actually haven't published a full description of the platform yet, because everyone that we have on the platform now is trying to do science on it. Okay? And it's coming together. So this is Dan just published a paper using the platform in which he identifies new, relatively undescribed brain connection. These are major tracks that go from the top of your brain in the back to the bottom, connect parietal cortex to areas that look and recognize objects. This is Brad, another student in the lab, and Nico as a collaborator. We're working on some spark concussion-related studies. We're looking at property of the microstructure of cortex, the surface of the brain, and we're looking at property of the major highways of the brain, these brain connections that we all know and name. And we're trying to identify early biomarker for CTE, like with the idea, can we identify different type of individuals that might be more at risk for developing CTE later in life. And we're using machine learning to do some classification. We have different groups of participants. We're testing different models, things that you guys are pretty good at, right? And that actually very exciting results here. We had 90% performance in some of the classifications. This is Lindsay, another graduate student. Lindsay has been looking at relatively unexplored aspects of the brain, shape. She's using Laplace-Beltrami operators, very simple 3D way of describing, getting features that describe complex 3D shapes. So Lindsay takes highways of the brain that have these canonical shapes that everyone are, that's the arcuate fasciculus, looks like a banana, connects you from here to here in your brain, and it's actually fundamental for reading and language, okay? And what we're doing, we're looking at populations of individuals, like thousands of individuals, looking at the variability in the shape. So what we do with the Laplace-Beltrami, we try to reconstruct the shape of these tracks. These are different tracks, the original. These are different, let's say, parameters in the model. Low parameters model don't do very well in reconstructing. Better, higher parameters model reconstruct the shape much better. We know at a certain point we can cross-validate how many models we need so that we can reconstruct and predict individuals. What we're doing here, for example, we can get up to 90% classification for taking some of these track shapes and identify individuals with attention disorders. We also tried, okay, the interesting thing is that that track has been studied for years, and we know it's related to attention. It turns out that's the track that comes out in the best performance in classification. We also look at people with bipolar disorders, same with up to 90% classification, and schizophrenia. So there's information across large populations, and you need be able to compute at this level to actually address these questions. This is Brent, very exciting work that we're writing up now. It's one of the other projects being developed on the platform. Brent looks at connections, this one, connections between different parts of the brain. And these connections are been studied for many years. You know, the way these labs work in neuroscience, my lab and other people's lab, is that I'm specialized in connection, someone else is specialized in function, and some labs are really good in memory, some labs are really good in language, right? And you study how language changes over time in aging. And what we did here, we took a large data sets from Cambridge, and we actually tried to put together many domains of behaviors and many domains of brain, brain extracted from the networks to try to predict the aging process of individuals. So this is the results that we have. I'm very excited about this. So this is a canonical correlation plot, okay? Standard correlation correlates two variables, right? Here, think about correlating two domains. Okay? There's about 300 plus variables, task, accuracy, reaction times, questionnaires, ratings, right, that come to these axes. And on this other axis, we have brain network statistics. And what we're trying to do, can I predict the aging process of, or can I predict the behaviors of these individuals given the property of their brain network? And you see from the shape of this correlation, actually, it's pretty good. It's 88, okay? Now, you see the color map there. The color map is age of those individuals. That color map did not enter the model. So the shape of this plot is independent of the color map. We laid out the age on the individuals without using age in the model. So we have a prediction, actually 66 is the correlation, pretty good prediction of aging without using aging into that. It's a classical live-out approach. Very excited about this work. So to sum up, can we use these platforms to engage scientists, convince them that they should come, it's valuable for them, can improve their work, to come on this platform and do something useful, share the data, share their code, commit that time to commit on their code, okay? It's a thing that I see as I go with graduate students. They love doing research, and they're worried at the beginning committing to what they've done, right? This is a process that probably in companies, part of what you do. Many times you just check the code into a code base, right? But that is not the normal process in academia. In academia, everyone develops their own little repository. Unless there's a management style in the lab that is different, normally scales. Anyway, so we thank the funding. This is started with an initial grant. Actually, started with a grant from the Big Data Hub that led us to develop the prototype. And we used that funding to then write a grant for the Brain Initiative at NSF. We got that grant. Meanwhile, with the help of Vani, we got some funding through Azure and the Hub. And these are all the collaborators. You, Lindsay, Dan, Brent, Nicholas, Bradley, Paolo, and Soichi, who's the mastermind behind most of the development. Thank you.
So maybe we take a couple of questions and maybe a comment about how all this ties together and how the work that Franco and team are doing on BrainLife applies to the broader citizen science work that we in Microsoft are trying to support with support from the NSF. Do you have anything to say about that, Pedro?
I might. So when I first saw this talk, or a version of it, I was really impressed. This was at the data science workshop, and I thought, this is so sensible. You know, this is one of the stepping stones, right? This is the glue that allows us to take data and algorithms from different stakeholders and create workflows and ensure with registration in a library and metadata that there's compatibility among these things. And then these are like Tinker Toys or Legos, and you can do research and you can move them around and you can do A/B testing. And I thought, we need this for human-machine partnerships too. We need to extend this into the space of crowd-powered systems. And again, it's these feedback loops. We want to take the crowd-based data and then train the machine learner to make it better, or figure out which architecture works best, and do this in real time. Have dynamically improving machine learners that are also contributing to a broader analytic platform. So to make these kind of, living things that are self-improving always is one of the goals, and to reduce the amount of the tremendous amount of time we and students spend on trying to fit these pieces together. So so I mentioned this to Vani, and I spoke with Franco about it. And we decided it might be an interesting idea to shop around, and we've been shopping it around within and without Microsoft, and so we haven't publicly said so, but we're going to pursue this in earnest, and we'd love to have everyone in this room involved in some way in making this a reality. You can sort of imagine that, in one instantiation, you have a community service provider like Zooniverse, right? So what if you have a data set and you want to analyze it in Zooniverse, and then you want to have somebody do machine learning research on the stuff coming back out of Zooniverse? Well, now these are all pieces in a system. Zooniverse has an API, and this system has an API. And you can make these things work together. You can do your A/B testing. You can focus on the science as opposed to the machinations required to do the research itself. So, so I'm very excited. This is the first time we've sort of shared this idea in a group setting. I'm thrilled to be able to build on Franco's excellent work, and And it's really a pleasure to engage with Microsoft Research and discovering just, the amazing work that's being done here. And I think this could all come together in a really useful way for all of us and for society. The name of this framework is Civium. Civium is the Latin word for citizenry. So anyway, that's my comment.
I was going to show you the type of practical problems, right? Imagine when you start generating, so for a conference in May, we generated about 250,000 brain images. Okay, these are actually 3D images, point clouds or volumes, okay? And so there are more, right? And on many of these, we know we have some artifacts. And ideally, we like to have an API to publish. We could publish on Civium if we get some funding to develop it. We can publish on Zooniverse if that's a possibility. We're trying to partner with entities that are interested in helping us, right? To go to scale, partnership with humans seems great. Partnership with AI seems also very valuable. We have basic heuristics that we can implement to identify some of the artifacts. Some of them are really hard, okay? So we don't have heuristics. So if we do succeed in engaging all these researchers into analyze data, and we start generating so much data that it will be impossible to do quality assurance on the data without having partnership with some sort of intelligent through AI on individuals. That's why I hope we get to work together more.
We'll still break for lunch at, did you have a question, Lucy?
Well, I was just wondering, I actually have a comment, but I can do it whenever you think it's best.
Yeah, no, you can do it.
Okay. Yeah, sorry. Yeah, this is fantastic. It's really great to hear about this. I guess, so one, devil's in the details, right? And so, one of the things that Zooniverse has been trying to work on, just with one project, the Large Synoptic Survey Telescope, which is, our next big thing on the astrophysics side. So it's a hard process to convince leadership of these large, billion-dollar enterprises like this to get something like the Zooniverse embedded early on into the data pipeline. But we managed it. So that was hurdle number one. So when LSST goes online in the next year or so, there will be the opportunity for scientists working with LSST data to, quote unquote, spin up a Zooniverse project, quote unquote, easily. Okay, again, devil's in the details. But the problem we're facing now is the scientists and their, going back to what you were saying, how do we convince the scientists that, even after all of the work we've done, we can show all these publication plots, we can show, sometimes it's just, they don't know that this type of thing, infrastructure exists. If they did know about it, then, they would avail themselves of it. So really it's a question of how do we, so this is a great, fantastic idea, awesome, let's do it. But, well, how do we get the news out? How do we convert scientists who feel somehow, for a variety of reasons, they don't want to put their data, as you were saying, it's my data. I don't want to, put my data or my, whatever. Or they're suspicious of having the crowd involved in the work. Just all these questions.
Yeah. I have a comment to make about that in the limited exposure that I've had in this space over the last couple of years or so. I think one approach that could work is start with the community approach. So where the community deeply cares about a problem, and then you go and find the scientists who are working on the problem, and you take the community's help in bringing the data onto the platform, and you take the community's help in engaging citizen scientists, which is what you've done with the Snapshot Serengeti project. And that's this whole, there's a very rich ecology ecosystem that you have enabled on top of Zooniverse, right? So that approach tends to be better, I think, than just trying to ask scientists to contribute just for the sake of reproducibility of science or so on, right? So I think
you have to show that there's a problem that they are concerned about that's being solved by this system.
Right. So, yeah.
I just wanted to interject in this conversation because I was really excited before you made the announcement about that idea of a platform, and I wanted to talk with you offline, and I'm glad now we can all do it online. I think it's amazing, and I had a similar thought to you with the question for you, which is, that's great when we create the platform, but how do we create a community? And so when I'm very excited about the space of human AI partnerships, and I've been exploring it for a number of years now, but I find I'm one of the few people in my very large community that's doing that. And it feels like we're all little islands, and so when I think of a platform emerging, I think that maybe must is too strong, but a good way to make sure that it survives is to make sure that we create a community. And so my question is, have you thought about that? And if so, what can we do towards that?
I don't know how to work this. Okay. I think that's an excellent question, and I think it's an echo also of what Lucy was suggesting, which is, I mean, there's still today skepticism in the community about getting members of the general public to analyze data. So I think part of the challenge here is what I would call mainstreaming. We're in a very AI-centric world today, and I think having a managed service, having an industry heavyweight like Microsoft that's saying, we have this thing, Microsoft is behind this. Ooh, you mean, oh, if Microsoft thinks this is good, maybe there's something to this. And I think the work we actually do, I think bringing use cases with high visibility into this platform early is going to draw tremendous media attention. It's the new AI. I mean, I'm calling it that. It's always been a sub-branch of AI, and so as you gather more media attention and potentially controversy, which can be a very good thing when you're trying to generate visibility, then these questions come to the forefront, and people and scientists will say, I don't trust the public to analyze the data. Well, now we have this platform that allows us to demonstrate more effectively and repeatedly how you can effectively get even better data from a crowd than from an expert. In our own platform, we've actually demonstrated that to the chagrin, actually to the appreciation of the scientists generating the data. They said, your crowd is not aligning with our analysis. So we sat down, we looked at it, and they said, oh, your crowd is right. So, we need more examples of that. But I think it's a good question. It always comes down to humans, doesn't it? The challenge.
I think I have my microphone. Does it works? Yeah, great. So the way we are approaching this problem of engagement, it's multiple, obviously, but grassroots. Start from the students. Okay, cannot go to the leaders of the projects. You had to start training young people. So we started making videos, and we had lots to do there. We started rating self-organization. The whole platform has this idea that it should be easy enough that you can use it, and there should be short videos, which I show some of, that give you an idea of what to do. I think it's a cultural problem. It's not a scientific problem that we're addressing. And presenting at conferences, it's always the best way to do. We actually got good attention in the last conference. That was the first time we presented the platform. So I think in neuroscience, this is coming. NIH and NSF are requiring changes for data management and to sustain your project over time. And yeah, but definitely there has to be multiple approaches. It's not going to be one solution fits all. It's going to be collaboration between labs, visibility, partnerships, awards that give you visibility, papers that give you visibility. We know which one those are, et cetera, et cetera. So it's going to be a mixture of the old style process plus a grassroots approach or educating a new generation of students.
So on that note, Franco, when you say educating the new generation, are these people who are scientists in other sciences other than computer science, or are they, because I feel like there is this gap as well that in computer science we generally optimize for ourselves. Yeah. We have no idea how our models are going to be used by the other scientific communities. Even now, like when we talk about human-AI collaboration, we talk about collaboration where you know what you're looking for. But what if you don't know as a scientist? What if you just want to look at the data and who knows what comes out of it? Like you might have an hypothesis, but something else come out. And we don't often design for that type of collaboration. So, do you see that?
Yeah, so I've been trying to, and I might succeed in pitching to my institution to teach a class called Neuroscience for Data Science. Right? The idea of how do you understand the data, which for data scientists, it's the file type, right? Or how you read it, or what are the questions that people might be asking. A very simple overview of where the brain is and what it does might be enough to go a long way for getting some computer scientists interested in that type of data. And there's a lot of companies and there's a lot of good that can come out of actually engaging them into trying to understand the data and clarify the data. So that's one class that can happen. It can happen in different versions. And the other class should be probably a data science for neuroscientists, because definitely our generations of graduate students in psychology and neuroscience, they need to become more proficient in computing, because things are getting out of hands for them, because the algorithms are becoming more and more complicated, and the stack of software is becoming more and more complicated. So, in my small world, this is what I'm trying to do. I'm trying to teach a class in the engineering computer science that teach them how to handle and know anything that people are doing in neuroscience, and then teach in psychology and neuroscience, GitHub.
Identified some questions through these talks for the breakout. It's a small enough group that if anyone has input about any of those questions, I'm especially interested in the first one. So if anyone has experience or any ideas or input about these questions, we can just have an open discussion.
I'm happy to start. So, I mean, full disclosure, I have a paper under review about this, so I'm going to go ahead and spill the beans on that one. I think that there's been so many individual islands of people proposing human AI partnerships, and simply surveying, categorizing them, and perhaps putting them all within the same platform online allows us to start thinking about these workflows in a, like it becomes very formalized. As a computer scientist, I was trained in abstract patterns about, like, if I want to program for different scenarios, I can go and get these abstract models. I think it should be the exact same thing for human AI partnerships, where we have these abstract models. We know about them. Different people are doing this in different communities. And if we can put them together and put them on a platform, all of a sudden we start to have this mix and match space where we can start to think about what's not being represented there and move forward as a community. So I think the first task is just taking toll and putting that together. And if I were to push that to the next task, is when we have these abstract patterns of partnerships, then each group can talk about what are the scenario, they can talk about how is the performance of those patterns on their own data.
Right, so, as humans love to do, categorize, right? Right. And it's how we make sense of the world, right? And but I also want to. This is kind of a tangential bias, but one of the biases I have come up against is in working with people who specialize in machine learning. And when we're sitting down to try to develop the best combined AI with humans, they're very arrogant. And they say, oh, no, we don't need the humans. We can just, we don't need the Zooniverse volunteers for this because we just, object detection is a solved thing. And we don't need any validation of the object labels anymore. We now, we're done with that step. We don't need the humans anymore. And I keep trying to push back and say, but you can actually improve, And so, there's this sort of retraining or rethinking from you said the AI bubble, right? I couldn't agree with you more because at some point that type of thinking is going to burst and they are going to be confronted with this stage where you can't, you really do need the humans in the loop, and to try to retrain the computer scientists to think more about, I don't have to get the most accurate model. Somebody said, I think AJ said this, I don't have to get the most accurate model. I just, what is best? What does best mean? And so going full circle in your categorization project, how can we kind of provide sort of a reference point of, what's best? If I have a machine model that works, its confidence is not as good as the next one, but the next one requires a huge amount of attention in fine-tuning and is really brittle and is going to break on the next set of data you pass through it. So it's these kinds of metrics that I think we really have to use in your categorization project if I'm thinking about it the way you were trying to think about it. Yeah, sure.
So as someone who comes from the computer science discipline, I don't know who you're talking to, but when I heard you say the response you get, had a sense of why it was being said. And so when people say it's a solved problem, and I probably use that too when I talk to people, it says that if I, as a researcher, were to approach that, it wouldn't be interesting. Right. It's not novel and new. And I think the challenge is how do we create an understanding, and I like your idea of evaluation metrics, and then more than that, it's also how do we reveal what's challenging and new? And until we show for a computer science community that these issues are generalized, it's not about one data set, but we look across all these many data sets and we see the same trend emerge, I think that's how you attract a community of people who are going to do algorithm research, because it says this isn't a one-off, this isn't just an outlier, this is an interesting problem. And I think it's an onus of people who are trying to promote human AI partnerships as an important problem to study, that we have to prove that it's a general problem. And until we do that, I think we're always going to get pushback from the mainstream hardcore algorithm people to say, look, that's great. It's solved because we know in most cases you get enough training data, it's solved.
Oh, HA also had something to... I'll be quick, and then so I just wanted to add to especially this kind of notion of hubris among ML researchers that you occasionally run into, and I mean, I think it comes from a good place. I think it's there is kind of a fervor, which can be a scary thing, but there's a fervor around just some of these very tantalizing results that we see in ML. But I think, being able to spin out more examples of places where, even with infinite training data, the ML is just not getting there is going to help kind of catalyze appreciation, maybe even among machine learning researchers for pure machine learning researchers for the value of doing it this way. And I think Stoll Catchers is a great case study, and we're going to publish on this topic. But the first question we asked is, why can't, I said I was going to be brief. I yeah, see, self-report is awful. So the first thing we ask is can the machine do it? And we really kind of went through the rigors to make sure that, no, the machine only gets it 85% right. So then we already know we have a reason to use a crowd, but then it introduces the question of why. And I think, you know, when machine learning researchers can start to realize the value of that, to be able to understand, well, why is it that humans can do this at 99% and the machine can only do it at 85%, then that creates a new target, you know, hopefully a qualitatively new target for machine learning or AI research. And in our case, it's about real-world knowledge, physics, you know, fluid dynamics, because you're looking at these blood vessels. Sometimes they're overexposed. You just can't tell if it's flowing or not. But if you look at surrounding vessels and the flow patterns and you can see the network, you realize that if it's moving here, there's nothing flowing here, and there's something coming out here, it has to be moving. Even if you can't tell, you know, because as a child you played with a garden hose. So that means, okay, so now we have to build this kind of knowledge into an AI. It sets a new trajectory for AI, I think. So, sorry.
Problem. I actually changed what I wanted to say listening to you, so that was actually useful. I think it is kind of misleading to present citizen science platforms to ML researchers or AI researchers as a platform for data. I think the collaboration needs to be much closer and stronger than that, because, you know, as somebody who's been playing a lot with the citizen science data, I usually have a very hard time to know what is the goal of the scientists. What are they really trying to accomplish? Because most of the time it is not getting some accuracy number to a level, it is finding the cases that do not fit to the current taxonomy, these surprises, or, you know, maybe it is not, the accuracy number doesn't have a meaning, but they really have a goal with this data and we really try to get to that objective. And I think we have to figure out a way to connect the scientists who are benefiting with these platforms to the people who really want to use this data to solve a real problem with AI, and somehow have that collaboration much stronger between the two sides.
Right, exactly. And so, you know, going back to your point earlier about, well, you know, it's a solved problem means it's not interesting to an AI person. And, you know, what AJ is saying and what I also think it's, okay, but, well, several things. But so when you involve humans in the loop and AI is changing as fast as it's changing, right? So you will get into these situations where there will be, you know, from the AI researcher perspective, it's like, oh, well, that's just a solved problem. But the scientist is like, I don't care if that's a solved problem from the AI perspective. I just need the tool that is going to get me the thing that I want most. And sometimes it's this disconnect between the scientist being able to express his or her goals and the AI specialist saying, well, your goals as novel research aren't the same as my goals as novel research, so this isn't an interesting problem for me to be working on. You know, it's how to convince kind of both sides that maybe from the scientist perspective, the data that the AI researcher is interested in isn't necessarily interesting for the scientist, and vice versa. So it's really narrowing in on what are the two sides want out of each other? How do we define this relationship so both get something out of it? I know that was a bit rambly, but that was, you know, the end.
Can I follow up on that? I think I'm on, right? Actually, this is precisely what should be happening, right? You asking us, like, we should be getting into rooms and having collaboration, right? You asking us, what question do you guys ask, right? And I should ask you, how do I ingest my data into your system, right? So I should be asking questions that I don't know about the engineering, and you should be asking questions that you don't know about the science that we ask. So we need to have engagement points, and workshops, it's a start, right? I think it has to be continuous and long-lasting more than a workshop, probably.
So I think your point is dead on. I agree with what you're saying, which is it's how do you align the value, like the goals of the two communities. And I would actually like to go further and say that I think that people have already proposed solutions that seem like it could be a good fit for that. So I don't know if you followed Kaggle. Okay, so Kaggle's one place that's kind of tried to solve it, but they didn't go all the way. And my collaborators actually spun off a new company that in the past year, which is actually a place where prospective employers post data, and someone's talk actually talked about this kind of model, but you post data, and then people who are interested in getting a job at the place come and they compete in this data set challenge. And then at the point that they compete, if their work is good enough, then they might get a chance to get an interview and get a job. And so I teach students introduction to machine learning, and they're eager to get jobs. And a lot of them they'd be delighted to work in a lab. And so if you have people posting data where it could turn into employment, I think you would find that lots of students and people looking for jobs might land in the right place. I don't think researchers are going to be convinced to, I think that it would be harder to sell to an AI researcher to come and work on these kind of problems, but I think there's so many people who would dive into these problems, and I think it's the next generation of students. And if that was something that happened, frankly, I would have my students. Every year they get to choose a project, and I know a whole bunch of them would probably choose to take data sets from scientists because that's a really cool story to tell, and it might turn into a job when they're done.
Hi. So coming back to Donna's point, I previously worked at a startup where we were trying out one of the ideas was to try this model where we would post data on a platform and have people come and take part in the challenge to offer a job. But I think one of the issues or like the points that was raised was how ethical is this? Like we have people having, you're getting people to work on your data, and is promising an interview enough of a reward for the work that they've done? And we ran into some issues of ethics around this, and I think, but that's an interesting model. Just
yeah, I think, Divya, that's an excellent point, and so, I mean, I think an inevitable consequence of the rapid proliferation of human-in-the-loop systems is going to have a concomitant rapid proliferation of ethical questions. So I think we need a conscience committee, to watch that, and I'm glad you raised that. And I wonder, sort of getting back to this question of creating collaborations and the quid pro quo, and just because it's a win for you doesn't mean it's a win for me. I wonder if having a platform or framework like Civium takes a step toward addressing that in the sense that you end up with artifacts that are produced. So if I'm a researcher with data and I want to do some kind of machine learning analysis, I can go and find machine learning artifacts and apply them directly without having to fully understand, the inner workings of those things. Or similarly, if I want to, if I have a MOOC, so there's this concept of a community provider. So if I have a MOOC, that's a community, and if I can build an API that ties into this, then I can draw data that serves whatever educational purpose my MOOC has from there, and in the process, data are getting analyzed and getting fed back in, and someone else might come along and your trash is my, what's the expression? One person's trash. Treasure. Thank you. Treasure.
So I think with that we should wrap up. Thank you for your comments, everyone. I think this is a really good group of people to get together. It feels more like an executive briefing session than a workshop. So yeah, on behalf of Bessa and myself, thank you so much for your talks today and for the rich discussion. Lunch is served outside. You can bring your lunch back in here, or is it in the meal room? Does anyone know? I guess I should know. It's in McKinley. It's in the meal room where the meals for the conference were. So you can continue discussions over there. Yeah, you should move over there. You should wrap up from this room.
Thanks to
Thank you.
For organizing.